Now we go to chapter 9, how behavioral approach gives new insights into risky decisions and applications of that. And we'll do two applications, both of prospect theory, one in quality of life measurement for the health domain, the other in insurance. We start with the first. And the quality of life measurement, for instance, is used to determine how bad it is to be blind. For maybe if life, usually they use a scaling that, which is convenient, that perfect health is given utility 1 in the health domain, quality of life 1, and being dead is quality of life 0. And then we wonder on that 0-1 scale, where is blindness, for instance? Is blind, is it 0.95? Is still 95% of the value of life maintained and is 5% loss? How much should we judge that? And those decisions and evaluations are important when we determine how much money we spend on which medical treatments. We of course do it where we have the biggest gains, and these measurements are used for that. I show you a common way of measuring quality of life of being blind, of health states. So the standard gamma question goes as follows. You present a patient, or maybe a group of patients, let's say one patient, with a choice situation where you say, imagine either you have a life where you will be blind, or you can choose a medical treatment where with a good probability P, you will get perfect health with vision, but there's a risk of dying, probability 1 minus P, you die. And then you can imagine if you such hypothetical choice, if you just like that, throw them at people, they start screaming and they say, are you crazy? Of course, this is done with very good preparation, with good psychologists in the team, and explain everything careful to the patients. And then such questions can be asked in a meaningful manner. And if this is done, and then we ask the patient, tell me which probability P here makes you indifferent. So which risk of dying are you willing to take for the possibility of getting back vision? The patient will give some number P, and we assume it's done carefully, so it's a good answer representing how the patient feels. Then come calculations. That's usually based on expected utility. So we do expected utility calculation. The expected utility of that right prospect, the risky one, is P times the utility of perfect health, that's 1, plus 1 minus P, the utility of that is 0, so that's simply P. Now, under expected utility, to have this indifference means that the expected utility of this option must also be P. But this is just sure thing, you're blind, so that means the utility of blind must be P, then also under expected utility. So then people use this measurement, say this is the quality of life of being blind. And this is a common method used in the health domain. And then on the basis of this, important decision, policy decisions are taken, like should we rather spend money on helping people to get back vision or on dialysis machines or whatever it is. But of course, we, with our behavioral background, we're a bit amazed because expected utility doesn't work as well in Berkeley. Like this measurement you're doing here is with a real human being, a real patient who behaves empirically as we know all people do. And prospect theory is a better account of what is happening there than expected utility. So there are quite some people now in the health domain who know about the behavioral ideas and start using it, but not as much as in economics. In health domain, more is yet to be done to propagate the behavioral ideas. But of course, they are useful to get better insights. Let me show you one example. If we reanalyze the situation, but we use prospect theory, we get quite different numbers and calculations. And I'll just show you the formula in a moment. So with that question and assuming prospect theory, we get here a formula. If the patient gives answer P, that means quality of life of being blind is this form. This form you need not memorize it. So it's a bit, well, you know, this is done. So this was proved in a paper where I was a co-author with some other people. And here W you may recognize, probability weighting, you've seen that before. Lambda I didn't explain in this course, but this is about loss aversion. So anyway, this actually you can read it in this homework paper that you can do for homework. But anyway, the formula, you need not memorize it. They showed the right formula on the prospect theory and they use it for discussion. So then they drew a graph. So they made the common assumptions about what is the prevailing pattern of W and lambda found in the general population. And then they came with this curve. And here in this curve, you have the P, that the probability that the patient answers, and U, that's the utility, the quality of life corresponding with it. They said we think it is that blue line is better than this diagonal. Classical theory expect utility is simply whatever the answer P is that they took for quality of life. They took the diagonal. The formula I just showed you, it gives this curve, and you see it's much lower. So the quality of life loss is much more serious than classical theories have it. Classical theory are greatly overestimating the utility values and underestimating the risk aversion that comes with all kind of things like that. So things are very different if we use prospective. And I think prospective is empirically more realistic. So I think the blue curve is better telling what quality of life is than the red curve. And if in health domain, how a decision are made, how much money to spend on diseases, the blue curve will give better decision, better reflecting what is good for people than the red curve. So much work to be done in the health domain to propagate behavioral ideas there. One thing that the authors showed in the paper on the previous slide was a problem. There's a problem in expected utility. That is, if you use different measurement methods to measure utility that according to the theory should give the same utility function, in reality they give different functions. So we get inconsistent utility measurements. That's one way to falsify expected utility. But these authors show that if you use the prospect theory formulas that they propose, then those methods give consistent utility functions. So then consistency of utility is restored. That's of course, you need that, you want that if you want to have a valid concept. So that was one reason for one way for the authors to argue that this was an improvement. And well, many people have the feeling that prospect theory is an attack on common economic concepts. I rather, the way I like most to see prospect theory is it is restoring, defending a classical economic concept being utility, because prospect theory gives us better, consistent measurements of utility. And I think expected utility is a rational thing, and we need a utility function there. So prospect theory is a better empirical method for getting that tool that we need in rational decisions. Prospect theory restores utility measurement. That's what I like most about prospect theory of all things. Anyway, so it has that's a constructive purpose of it. And I think you also get quite better policy recommendation based on these numbers. Now let's go to the second field, insurance, what the insights we get from prospect theory for insurance. And insurance, many things will be changed because of it. Maybe in insurance, when you first learned about decision-making under risk, and first time you were taught about expected utility, probably people told you that people are mostly risk averse. The first example you hear about it is insurance. Then you're told this means concave utility. That's, I guess you remember that happened. But with prospect theory, everything is turned upside down. So now let us go behavioral. First of all, we note that insurance is about losses. You may lose bike, house, whatever it is, and you pay a premium. It's all about money that you lose or other things that you lose, losses. Well, prospect theory, there have been many empirical measurements. Prospect theory, utility for losses, if anything, it is more convex than concave. Now that's already a big change relative. For many centuries, every textbook in economics wrote people are risk averse and utility is concave. Now prospect theory, well, for loss, we think it's the other way around. Utility is convex rather than concave. That's already quite a big change in views. But then if you start thinking about insurance, maybe you feel puzzled at the moment, because convex utility, if anything, is increasing risk seeking, makes people less willing to take insurance, for instance. So if utility is doing anything, it is keeping people away from insurance, not explaining insurance. And you think, well, but we know that insurance exists, so what can prosperity theory say about it? Well, first of all, maybe I should say many factors play a role in insurance that have nothing to do with decision theory, but other things. But the part that decision theory can capture, that it means insurance has nothing to do with utility, but insurance is due to probability weighting, to the overweighting of small probabilities. Maybe if you insure your bike, there's a small probability you lose your bike, 1/20, I don't know, but you're overestimating it. You're taking it too serious, and that is why you are taking insurance. Not utility, but perception of probability is driving it, as far as decision theory is concerned. So you already see that here you get a story that's completely upside down relative to what have been taught to you before. The insurance was explained by utility. It's not at all. Utility is the opposite of what they said. Something very different is driving insurance. So here you have another example how prospect theory, the behavioral approach, gives very different and I think improved insights into all kind of things happening. If you want to understand why people do insurance, how you can change it, study probability weighting more than utility curvature. Anyway, that was what I wanted to say about decision making under risk. Now we go to chapter 10, the new insights that the behavioral approach gives for intertemporal choices, and that will be in the next recording.